Here the roots are 5 comma minus 3. So next time you write next time the characteristic roots are therefore the general solution is S of A equal to let me see who gives the correct solution here. So you go to your procedure again. In that procedure comes under which category? We are in step 3. The roots are the distinct are repeated. Distinct are repeated. Distinct doubtly repeated the number the roots are repeated. So previous problem roots are repeated. So step 3 second subdivision. Now the roots are distinct. Where repeated. So step 3 first subdivision. First subdivision that what is the format of your solution? S of A equal to V1 into A1 power K, right? What is A1? A1, A2, etc. A in the end solving by everything described in your procedure. What are A1, A2, etc. A? 2 minus 3, 5. 3 roots. So n value is 3 here. So A1, A2, A3 you have 3 roots here. You have 3 roots here. So the A1 power. So S of K equal to V1 into 2 power K. 2 A1 power K is okay. V1 into 2 power K plus etc. V2 into minus 3 power K. This K is the variable here. Then V3 into 5 power K. Is it okay? And this is equation 1. And this is equation 1. Next one, given as per the question, what are the initial conditions given to you? S of 0 equal to 0. S of 1 equal to minus 35. S of 2 equal to minus 85. Just listen, you got it. So these are the given initial conditions, right? One more information before proceeding further. If you are having 2 variables, how many equations you need to have a good solution? For 2 variables you need how many equations? For instance, 5x plus 4y equal to 3. If I give 1 Can you tell me the next step now? So further you have to substitute k equal to 1. Is it there or not? K equal to 1 in equation 1. K equal to 1 in equation 1. What do you get? S of 1 equal to V1 into 2 power 1 plus V2 into minus 3 power 1 plus V3 into 5 power 1. That will imply what is of 1 value? 35. 2V1 minus 3V2 plus 5V3. In other words, 2V1 minus 3V2 plus 5V3 equal to 35. This is equation 3. Is it right now? What's the next step now? Put k equal to 2 in equation 1. What will you get? Equation 3 value? Minus 35, right? Yes, minus 35, right? Please change it now, minus 35, right? So it's equation 3. K equal to 2 in equation 1. What is that? 4V1 so S of equal to, we are putting K equal to 2. V1 into 2 square plus V2 into minus 3 square plus V3 into 5 square. That will give you S of 2 value is minus 85. Minus 85 equal to 4V1. 4V1 minus 3 the whole square. Plus 9. Minus 9. Plus 9. Minus 3 the whole square become plus 9. Plus 9V2 plus 25V3. In other words, this will become 4V1 plus 9V2 plus 25V3 equal to minus 85. Solve 2, 3 and 4. Solving 2, 3 and 4. I need the values of V1, V2. Anybody got it? Get the values of V1, V2 and V3. Anybody got the values? V1, V2, V3. Yes? 1498. You can solve either by elimination method or by substitution method or with the help of the calculator also you can solve very well. the answer. Anybody else who did it manually? 1, 4 minus 5. Answer should be 1, 4 minus 5. See, okay. Take one solution. Solving 2, 3 and 4 we get V1 equal to 1, V1 equal to 1, V2 equal to 4 and V3 equal to minus 5. V1 equal to 1, V2 equal to 4 and V3 equal to minus 5. Okay students, next substitute this in equation 1. From equation 1 the general solution is S of k equal to answer for the solution students. From equation 1 the general solution is S of k equal to what's answer? We know now the values of V1, V2, V3, K alone will be unknown. K alone will be unknown. All the constants we know now. So what is V1 value? V1 value? 1. So 1 into 2 power k, right? So 2 power k, V2 value. Plus 4 into minus 3 power k plus V3 value. Which is minus 5. Minus 5 into 5 power k. Is the general solution. So answer is S of k equal to 2 power k plus 4 into minus 3 power k minus 5 into 5 power k. Next line. Solution of non-homogeneous integrating solution of non-homogeneous recurrence relations. Solution of non-homogeneous recurrence relations. Procedure for finding the particular solution. Procedure for finding the particular solution. Step 1. Step 1. First solution